We continue with our discussion on advanced financial modeling on the bond pricing and bond functions and details about bond functionalities in Excel. What we're going to look in this particular video is the recap of interest rate risk and the calculation of interest rate risk. If we remember or recall our earlier discussions for interest rate risk, basically interest rate for a particular bond is inversely proportional to the price of a bond. So interest rate is always inversely proportional to the price of a bond. If price of a bond goes up, the yield goes down, and that's basically what's the interest rate that signifies us, right? So if we have the price of the bond as 100 and yield required by investors as 6%, if the yield goes up, then the bond price will fall. If the yield goes down, then the bond price will go up, right? So there is a risk in terms of how the interest rate transmission plays, and this risk is basically what gets classified or denoted by this term called duration. So what does duration mean? Duration basically tells us that what is going to be the approximate price change given a small change in the yield of the bond, right? So what does duration? And this duration that we are talking about is what is the modified duration essentially, right? So when we say modified duration, if modified duration for a bond is 3, then what do we mean? If there is a 1% change in price, in the yield, in the interest rates, basically, that would mean a 3% change in price and in the opposite direction. Remember, price will move in the opposite direction. So if yield goes down, price goes up. If yield goes up, then price goes down, right? So a modified duration of 3 would basically signify that with a 1% change in yield, approximately 3% change of price should happen. If yield goes up by plus 1%, then price will go down by 3%. If yield goes down by minus 1%, then price will go up by plus 3%. This usually works for small changes in yield. So while, for example, I've shown you that that it is 1%, typically at 1%, this will start becoming slightly higher or lower. What it might work at is at 0.1%. At 0.1%, increase in yield, the price will fall by 0.3%. At 0.1% decrease in yield, the price will go up by 0.3% if the duration is 3, right? Now, how do I calculate the duration? What I can do is I can create the structure for a bond. I already have the cash flows for a bond. I can take the current yield and try and find out what is going to be the price, right? Then change the yield a little bit, just cut the yield down a little bit. I get a price. Increase the yield by the same amount, I get another price, right? I find the difference of these two, divide that by 2 into the initial price divided by the change in yield in decimal, right? Let's try this out on an Excel file and we'll get to our answer. So we see a bond here which has an 8% coupon and it has a maturity of 5 years that is there, and then there is a price and there is a yield. So yield is available at 7.2, based on which we get a certain price. So we find that the price at the beginning of our discussion, we call this V naught, is 103.26. We have kind of hard coded it, right? So we can just do a control C and paste it as values, right? Fix it as such. Now what we are going to do is we are going to change the yield a little bit. What is the change in yield? The change in yield is going to be 0.1%. That's what we are going to use as the change in yield, 0.1%, right? So we will first decrease the yield by this much, right? So we take 7.1%. If I change the yield to 7.1% here in the discount rate, price goes up to 103.68. So I will put 103.68. What is the change? How do I calculate the change? That's 103.68 minus 103.26 divided by 103.26. So the price changes by 0.4%. When yield goes down by 10 basis points, the price moves up by 0.4%, 40 basis points, right? Next, what do I do? So this is hard coded. Next, I change this to 7.3%, right? Increase the yield by 10 basis points. When we do that, we get the price as 102.85, 102.85. So what comes? The value that we get is the price reduces by 40 basis points. So it's fairly straightforward that I think the duration should be close to 4. When you change the yield, increase the yield by 10 basis points, price changes by 40 basis points. When you decrease the yield by 10 basis points, price goes up by 40 basis points. So that's a very straightforward calculation that we are getting. We should get this value of duration. Now let's calculate duration using the formula, right? So if I use the formula and calculate duration based on that, based on the formula, that if you remember is V decline minus V increase, right? Divided by 2 multiplied by the initial price multiplied by the change in yield, correct? And we close bracket and we get the duration as 4, correct? 4.02. That's the approximate duration that we get, right? And as I said, for smaller changes, this would work well. So on an average, you're getting 4.02 percent change on average, right? That's how you calculate the duration. So effectively, that's the broader calculation of duration. Duration is the measure of price sensitivity of a bond to changes in yield. So it basically tells how much will a bond move on a 1% movement in yields, right? Now an approximate measure can be found this thing. So we have this is an approximate measure by this calculation, and that's the example we just saw, right? Now you can also use a function called M duration standing for modified duration. Remember, there are two functions in Excel. There's something called as duration and there's something called as M duration. We are supposed to use M duration, right? Now M duration should give me the duration of a particular bond given its settlement, which is the trading date, maturity, coupon, yield, frequency, and basis. Exactly the same. Basis again being a number that tells you what is the convention being used in terms of valuation, right? What is the pricing convention used for the valuation of the bond? Is it 30 by 360 or actual by actual? That is what the convention basis tells you, right? So let's try and use this function called M duration. So for that, we go to our Excel file and we will write M duration here and use the function M duration and open the arguments for the function. So we'll need a settlement date and a maturity date. So before we go there, what we're going to do is we're just going to put a few dates. So let's assume that today is the date here, and then every date is just you add 365 to each of the years and you keep getting to the final date, right? You keep adding 365 and you reach the final date at the end of this, and obviously that's because this is a leap year, so you add 366 and rest of it works fine, correct? Now M duration is going to be M duration, and we're going to kind of open the bracket. Settlement date is today, C3. Maturity date is going to be the final date when the bond matures. Coupon is going to be 8%. Yield is going to be 7.2%, right? So it says 7.3, but we'll change that to 7.2 to arrive at the exact number. Frequency in our case is annual. We are using multiple days, and basis is also 1. That's what we're going to take. It's on an actual to actual data, right? And we click on OK. What we get on M duration is 4.03. Approximately 4.03 is the number that we get, right? And that's we can change this a little bit. The number might change here or there a little bit, and we get 4.03 as per this, 4.02 as per this, which is the approximate modified duration that we have found that tells us what is going to be the actual change in terms of the bond price based on this, right? Now, in terms of understanding of duration of a particular bond, there is another metric that comes up. And that parameter is called Macaulay duration. So you can calculate duration another way. And if we go back to our discussion here, you find that approximate Macaulay duration is approximate modified duration into 1 plus r, right? Now, the actual understanding of Macaulay duration at this point of time is beyond our scope of work. We don't need it because primarily only interest rate risk is needed, and that is available at approximate modified duration. But if we were to use this formula into 1 plus r, we are going to get approximate duration. So let's do this formula. If I take 4.03 into 1 plus the yield, that gives me a number as 4.32 or approximately that number. There's a function called duration. There is a function called duration which uses exactly the same parameters: settlement date, maturity date, coupon, yield, frequency is 1, and actual by actual. And if I use that, that gives me the Macaulay duration, right? So this is modified duration, this is modified duration, and this is Macaulay duration. We are more worried about the modified duration. M duration is for modified duration. Remember, that's what we need to keep in mind. That's basically the function that we use in Excel to calculate the duration or modified duration of a particular bond. 4.03 basically means that if there is a 10 basis point change in the yield, the price will change by 40 basis points in the opposite direction, right? That's basically about duration. And as we come to the close of this particular section, we just look at a couple of questions. What do we mean by modified duration? And if modified duration of a bond is 5, what does this mean? Thank you.